Hello everyone, we're going to plot some polar equations. These look pretty cool, they're a little different, so you get to make some fun shapes. First thing you got to do is go to Desmos, and we got to bring up the calculator. So Desmos calculator, but this is in XY plane. We call these Cartesian coordinates or rectangular coordinates. We want to be in polar coordinates, so click the wrench, and notice you got this guy right here. That's the polar coordinate, so there you go. Now we're in polar, so it's a little different game. We talked about plotting points yesterday. Desmos actually won't plot points like it should, so that's not as cool, but it will plot equations, so we can do that. First one we're going to do is r equals 2. So we're going to figure out what it does when it's r equals k. R equals 2. R to me sounds like radius. R equals 2. Oh, wait a minute. 2. Oh, look at that. It's a circle with radius 2. And if I make the circle 3, now the circle is radius 3. If I make it 1, guess what? It's 1. What if I make a negative 1? Oh, okay. Doesn't do anything. Yeah. Make it a negative doesn't do anything. It's just going to be the radius of the circle. So the absolute value is, if you can think about it that way. So what questions do we have here? What is the shape of the polar equation? It's a circle. And what does k determine? K is the radius. And what happens when k is negative? Nothing really. It's the absolute value. It's the absolute value of the radius. Maybe it's a good way. I think that works. Okay, so nothing too fancy there. You just get a circle. It's r equals 2. We're on the second ring. It would look like that-ish. Hard to draw with the mouse, especially on my thing. All right, let's try the next one. R equals k times sine of theta. And notice if you just write the word theta, Desmos is cool like that. R equals k sine theta, and it converts it for you. And we want a slider for k, and we got a slider for k. So k is 1. What do we got here? We got a circle with diameter 1, and it's centered on the y-axis. What if I do k is 2? Okay, k is 2. All right. What if I make k bigger? Oh, is this the diameter? 0.4? Yeah, that's 0.4. Okay, 0.4, cool. So it's a circle centered on the y-axis whose diameter is whatever k is. What if k is negative? So k is positive 2. What if I make k negative 2? Oh, okay. It flips it. It's under the, we'll say polar axis. I shouldn't really say y-axis. The x-axis we call the polar axis. So it's centered on this vertical axis. I'll say vertical axis. And it has diameter, whatever k is. So what's the question? How does k change as the diameter of the circle? And what happens when k is negative? Let's see, when k is negative, the circle, let's see, is below the horizontal. In polar, we call it the polar axis. So I'm trying to use those words instead of saying y-axis, because it's not really the y-axis. We don't have a y-axis on the polar graph. If said k is 3, what is the radius? If k is 3, the radius of the circle is 1.5 because the diameter is 3. So that's kind of a trick. Be careful. If k is 3, the radius is 1.5. Watch, when you make k 3, the radius is half of that because the diameter is 3. So just be careful. Where's the center of the circle? I'll say it's on the vertical axis. Now, you could also say it's on pi over 2 radians. That's pi over 2. Or 3 pi over 2 if k is negative. What else you got? That's k equals sine, or k sine theta. How about k cosine theta? What happens if I make this cosine? Oh, okay. So it's kind of the same thing, only it's to the right, and I bet if it's negative, it's going to go to the left. Yeah, okay, there you go. So it's the same game. It's just the center of the circle is now on the horizontal or polar axis, and the diameter is the same. So pretty much the same thing. What happens if k is negative? The center of the circle is on the left side of the vertical axis. And what is the radius of the circle? Again, 1.5 is the radius if the diameter is 3. And where's the center of the circle here? We'll say on the polar axis, which is the horizontal axis. Okay, this we call the polar axis. What else you got? So we had our sine theta, that was a circle above the horizontal axis. Our cosine theta, that's to the right and to the left. And now we got a cosine b theta. So there's a bunch going on here. A cosine b theta. A cosine b theta. I'm going to make sliders for both of those. I don't need this one anymore. So a cosine b theta. That looks like a circle to me, but maybe it's because b is 1. Whoa, okay, so something's going on, but this is going to be crazy. All right, a is 4, b is 2. Let's say a is 4 and b is, ooh, look at that. That's pretty. A is 4 and b is 2. So I'm just going to screenshot this to make it easy on myself. There's my first one. Look at that. A is 4, b is 2. How about a is 4, b is 3? When b is 2, there's 4 petals, but when b is 3, there's only 3 petals. That surprised me that b is 2 and there's more petals than when it's bigger. So we'll have to look at this. That's when we got these guys. Okay, that's cool, I guess. So yeah, you see what I'm saying? B is 3, there's 3 petals. B is 2, there's 4 petals. What about B is 4? Okay, I got you. All right, I bet I can generalize this. So check this out. B is 2, there's 4 petals. B is 3, there's 3 petals. B is 4, there's 1, 2, 3, 4, 5, 6, 7, 8 petals. If B is 5, I bet there's 5 petals. And if B is 6, I bet there's 12 petals. I think I got it. So if B is even, how many petals are there? There are 2B petals. Double it. If it was 2, then there are 4 petals. If it was 4, then there are 8 petals. So it's doubling it if it's even. If it's odd, then there are just 1B petals. Okay, so if you pick an odd number here like 3, then it's 3. How does A affect the graph? What is A? Oh, so this is just stretching it out. So that would be like the, what do we want to call that? It's like if this was a flower, it'd be like the radius of the flower. Or maybe you could say like the diameter of the petal. If it goes out 4.7, then it's going out. Let's just make it something easier to see. That's too big. 5. You can see that it's going out to 5. So I'm going to say it's the diameter of the petal, which you could maybe also describe as like the radius of the flower. I'm not sure what the best way of saying that is. I'm just going to call it the diameter of the flower. The diameter, or of the petal, rather. Okay. How do you spell petal? I think so. All right. What else you got? Oh, that's it. You got a checkpoint to do. So you have a polar graphing checkpoint. You already did the plotting polar points, so now you just got polar graphing. And folks, that's a wrap. That's it for the year. So seniors, congratulations and good luck. Be sure to hit that like and subscribe.